Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about hybrid display technologies. There is too much word salad happening, so I could not find a title. So what exactly is the problem that we need to create this? Well, reality is we don't have a perfect pixel technology, meaning this is what we want. Basically, what we call direct LED. So direct view LED is the best technology. We have this. This is used as an advertisement, outdoor display. This puppy can stare down sun and still look good. So there is no discussion. Contrast, great. Brightness, ultra great. There is no, and not to mention, these are modular. So even if some part, like, bad pixel happens, you just swap out the part, the end, go home. So this is great. And you can see these puppies are robust, long lasting, actually used in outdoor environment. So they are perfect. Then what's the problem? Well, we haven't figured out how to miniaturize these puppies. As in, while originally pixel pitch used to be huge, so you could have only seen old Linkin Park concert. It was the early days, so it was okay, but you could see even those are huge and you are far away, you could still say that's a low resolution. Now it's dude, you could be few feet away and it's a monitor, it's a full screen display at that point in time. And if you are few meters away, let's just say 5 meters, I'm pretty sure nowadays you can actually run a theater on these things and people will be like, dude, it looks good. So fundamentally, that's the final form of technology, but it is not ready yet. Now, my channel is old, so I covered this years ago and still too far away. That time Samsung was we are so ready to bring it. Yeah, in 2026 when I'm making this video, yeah, it's still not there. My expectation is it might drag on till 2030. Now, two major players that I know that are working on is Sony and Samsung. Both of them have deep enough pocket that it might work. And okay, that's our desirable things. So what can we do? Well, we can mix whatever we have right now. For example, liquid crystal display, it's a very robust technology. Even though ironically it has moving parts, it's very robust. So you have a crystal cell, and in that you rotate the crystal using electrical potential. So it's physically rotating, yes. If you have not even electron, I'm pretty sure you could see that if with a good microscope, you can see the crystals realigning, yo. So that does create a certain fundamental penalties. First, this is a filter, right? So it's an on-off button on your light. Now that makes your, calculator screens, watch screens, things of that nature, but not a monitor, because monitor does not need to go on and off. It has to gradient control it, as in, be on 1%, be on 35%, be on 27%, that level. You need variability, 8-bit depth, color depth. So depth in this means you have the ability to drive each pixel in such a way that it can be either on or off or somewhere in between. Where is in that somewhere? 256 level on a 8-bit panel, on a 10-bit panel, 1000 levels. So if you have a 10-bit panel, true 10-bit panel, it looks good, because when it's when it is doing color mixing, it needs lower level of red. 1024 switch level allows you to go much fine-tuned compared to 8-bit. 8-bit is it's here, it's or here, make a decision. Here, if it's a 10-bit, it's I got you, fam. I got you. So color mixing is fundamentally better. So okay, so it has some pros, some cons. Robustness, very good. We have mastered this technology for so long that this is, you buy and forget. You can buy a quality branded LCD and it could work 10-20 years from now. You can trust it. I have old computer monitors, they still work. You can buy junkyard monitors, they still work. So fundamentally, they are long lasting. That part is sorted. It's just that quality is not that great. So what if we mix other technology into it and get the best of the both? Basically like a composite. You do not make your building out of rebars alone, nor you make your building out of concrete alone. Have them, these two puppies together, voila, reinforced concrete, best of both worlds. So same thing. What if we added quantum dot to it? What if we stacked it? Or what if we did some mix of things? So that's the idea. We want this. It's not here. It's not ready. What can we do right now? We have LCD-like technology or OLED-like technology. What if we mix two of them together? So let's dive deep into it. So quantum dots, this research happened 15-20 years ago, so to say. So this is a semiconductor nanocrystal alloy. Let that be clear. It's not a single element, it's an alloy. So it could be lead alloy, it could be gallium alloys, silicon alloys, whatever have you. It's an alloy. And core aspect is that you can control the growth of this crystal, as in the size you decide. And benefit of that is this puppy is a transformer. aka right now your color filter is you have a broad spectrum emission, as in like full, you have a white light, basically almost like sunlight, and you send it through a filter is like, I'm gonna block everything, only let the red pass, only let the blue pass. Now it does work, that's why you have color LCD. Problem is you're throwing away majority of the photon energy. Like you had 100 watts of energy, let's say behind the red pixel, and the red pixel is like, nope, only 5 watt went out, because again majority was not what you wanted. So that does create an issue. So somebody's figured out, like, what if we made this quantum technology known as quantum dots. This can eat high energy photon and downshift it. It's basically a high voltage to low voltage transformer, like how you have high voltage transformer in your neighborhood where it takes 11 kilovolt and downshifts it to 220. Same thing is here. It's like, what if I consume a blue photon, and what if I release 2 red photons? Now, I'm pretty sure it would be 4 or 6, but you get the point. Like, it always downshifted. And whenever you're saying, hey, wait, I have seen photos of blue quantum dot, yeah, they're not blue as in blue, they are being emitted by something higher, as in ultraviolet. So whenever you're seeing something glowing like this, they generally have a ultraviolet torch glowing this. Then only you can go to blue. You can't upshift, you can only downshift. This is a step down converter. Yes, there are crystals that can step up, but those are black magic technology. We do not talk about them. So quantum dot, people figured out, okay, first this downshift is, that's the best color filter you can ask for. So not only it will convert it, it will give you a very tight emission. So convert from your efficiency of 5%, now you have 75% or even 90% efficiency. It's like short uptake money, like your red channel of your TV became bright, as in like so bright that you have to actually tone down the LED behind it. You have to tone it down. It's like, whoa. So that's great. And here's the deal. If you shrink the size of the ball, crystal, so to say, you can change the wavelength. And that's the sweet part about it. Now we have 3 wavelengths. Basically, blue is blue itself. It does not do anything. As in like just tightens the spill a bit. Green photon, blue to red. So this converter has the ability to remove a filter layer. You can throw away the filter layer, and instead of filter layer throwing away the energy, it's like converting it. So far more. Fundamentally, it's a big jump. So that's what we do. And the law of physics that's happening is classified as quantum confinement effect. What does that mean? That simply means this whole crystal is not behaving like a crystal, is behaving like an atom. So whenever you're seeing band gap, and you're like, wait a minute, band gap is a material, not a material property specifically, it's more of an atom's property. But here, using quantum engineering, we figured out how to have this ball behave like it's a quantum material, as in full-fledged atom. It's like, think in this way, we are a human body, but we are a living thing, right? Cool, awesome. But here's the deal, how can a single cell can be a living thing if it needs this much? That's the whole point. So this puppy, it's so big, it has so many atoms, still behaves like a full-fledged atom. And yes, you have multiple wavelength, multiple use cases. We are focusing on its photon downshifting capabilities. And yes, it can downshift to infrared, it can upshift to ultraviolet, as in like if you have high ultraviolet, you can downshift it. It is doable, like it has wiggle room. Although I have not seen people saying that you can tune every single wavelength, more of like, we have this zone, because again, crystal lattice does require what you call proper count structure. You can't just have arbitrary numbers. Okay, I need this diameter. It has to geometrically fit those atoms count. So you will not have perfect slices, but it's more than perfect enough for what human eyes can see. And you would hear sometimes it's like, oh, it's organic. It simply means the core ball is not organic, but it could have organic coating, as in lipid coating. Do not ask me why Samsung does that, but they do. So if you ever hear organic quantum dot, that's what it means. It's the quantum dot is the same. It might be made out of lead, might be made out of gallium, but generally it might have a lipid coating around it. Why? I have no idea. So that's the quantum dot part. So quantum dot LCD. And I have no idea. I hate the marketing team. Somehow the LCD that we have right now, it's called LED. Again, we never called the main element based by the backlight. Backlight of TFT panels used to be CFL. We don't call them CFL. We simply say it's a TFT, it's IPS. I have no idea how the heck that marketing team got that BS stuck to people. People are in my that, oh, let's say, oh, sir, you should buy LCD TV, LED TV because it's the best. I'm like, it's just LCD with a LED backlight. So here's the deal. Liquid crystal system is something like this. Basically, you let light go through, and again, this is the key difference. When you are talking about calculator watches or something like that, they generally have on or off state. When you're talking about a display, it generally has gradation, as in it can on, off, or mildly on. That option is there. So no filter is absolute. And I'm not talking color filter, I'm talking this crystal filter. This is not absolute. No matter what you do, it will not allow zero photon to pass. It will only be like, I block it. Crystals are good, it works, but that's why the black in your LCD never looks black, it looks gray, because some photons are still leaking through. So it becomes full white, or as full as it can do, and low white, as low as it can do. So on computer wise, you are giving the command 0, give me pure black. It's like, bro, you can give me the command, I can drive the crystals, photons won't stop. So it does have some bleed problem, as in it will always leak. And color filters are not perfect. Now, if you have a broad spectrum light entering these crystals, it will have a what you call sub-optimum performance, as in blocking won't be as good as it could be. So somebody figured out, it's like, okay, right now we have a backlight, then we have the color filter, and then we have the LCD element. But what if you throw away the broad spectrum white LEDs? You take them and you throw them away, and you put a pure blue one. Very easy, very cheap, because there is no such thing as white LED. All you have is a blue light emitter downshifting via phosphor. Like instead of using phosphor, here you are talking about quantum dot, but that's the same idea. You take blue photons, downshift it into broad spectrum emission. Here it's laser-like. It's like, hey, I'm going to only create red photons, green photons, blue photons. So in blue, you do not do anything. Blue, you let it pass. Green, you have that, and red you have. And because these are converting, like basically taking blue photons and making more green photons, the luminosity of each colors match much more closely. As in, if this is 100 watt, this could be close to, let's say, 90 watt, this could be close to 90 watts. In the old system, it was like, yeah, blue would be very powerful, because again, it's blue direct, very powerful. Red would be very weak, and green would be hyper weak. So that issue is solved, meaning you no longer need the oomph. That's why you will hear people say, oh, it's more efficient. That's why it does not waste energy. So far more oomph can be get out of your display while consuming less electrical energy. So that's the whole point. Quantum dot downshifts all the wasted photons, and it gives you much better green, red. So your efficiency goes up. It does have leaky photons in this layer, as in the crystals will still leak some photons, but because you have pure colors coming in, like almost like laser light coming into it, the bleed is less. And you all have zero color bleed. So it won't be like, okay, some yellow leaked through, some this leaks through. No, the digital signal is red, blue, green. You do not need anything else. Do not convert it or do not add your own color to it. You don't want that. That's not desirable. So this has that advantage. So basically, quantum dot layer makes this work far more effectively, and your saturation improves, everything, luminosity improves, and it's bright and it's cheap. And you're like, how the heck it can be cheaper? Yeah, those super bright white broad spectrum LEDs, yeah, they are not cheap. And if you throw all of them away and just like, hey, blue diodes, the end, it's much cheaper. So it's there. But again, you still have that limitation, as in it will still leak some photons. So the only solution is backlight, make that backlight into like a full-fledged LED TV, which again, that's Sony's true RGB thing is, but again, idiotically expensive. So this is the best low-cost tool you have that you can buy and trust that this puppy will function for decades to come. So this is QD LCD or LED. I have no idea why that LED name stuck. Now we come to QD OLED, organic light emitting diode, aka polymer LED. So this, now you have the advantage that there is no crystal. There is nothing going like this. It's like on, off, on or off. And again, you also have gradation control, as in fully on or fully off. You have like 256 level or 1024. It's far more easier to do. But same problem. How the heck you give color to it? LEDs are still, organic photon systems are still goddamn blue. So they're like, okay, we're gonna do the same thing. We're gonna add color filters. So they added color filter, but it created an issue. These organic LEDs are not as bright. It can't go against sun. So they're like, okay. And again, if you're filtering it, and let's just say your computer gives a command, show white. It's like, how the heck it's gonna show white? It has to bright the blue full out and then have some dull white coming out. So LG was, hey, what if I make a WOLED? as in have a void pocket. That is, if computer detects, as in the processing chip and this puppy detects that it's supposed to show white, it will disable this pixel, this pixel, this pixel, and this pixel will full out. So it's the easiest way to add highlight, detail, and white without causing an issue. So fundamentally, you still need color filter. So it has some issues, lot of issues. Again, the LED layer here is much weaker, so you can't overdrive it. That's why you will hear for like few years, it's like OLEDs are great, but they're not bright. That's the reason. It cannot be hard and this burns out. And again, I have this OLED panel, half of area of it's burnt already. So I understand that from experience, this do not last. So what if instead of filter, lossy filters, you had quantum dot, and quantum dot instead of like blue becomes blue, it's not an issue. Blue becomes green, not an issue. Blue becomes a red, not an issue. So now your basically the actual emission layer, it's much more calmer to have a higher output, by the way. So for example, here, if you needed a red of, let's just say 25 lumen versus red there 25 lumen, this will consume far more wattage to deliver that versus that. So not only you are getting better color rendition, you are getting more efficiency, it's cooler also. So your lifespan of the panel is higher. So you can see that you had a very sloppy, because again, filter will never be absolute. So coverage was like, let's just say in this example, 76% of BT 2020 is the color space used for cinema. And this puppy now, because again, you have peaks controls, you can actually replicate 90% of it. Now, at that point in time, it's like, it's good enough, okay? And you're like, okay, isn't this peaky system will look ugly? No, your camera has that data. This bleed makes it worse. You might think it otherwise. No, you do not want that. Like if you go into IMAX system, IMAX, the highest IMAX, there is the organic IMAX that is like, 70mm film. Only few of them have that. Like few physical theaters have them. India has one which is not even a film theater, it's a documentary theater. All of them are Limax. So Limax used to have like giant xenon system and all that. Now, the next generation, true IMAX, they have 4K laser, but here's the, there is no white laser. They have pure red, pure blue, pure green, and using beam splitter to merge them. Why? Because again, the signal has blue data, green data, yellow, blue, green, red data. It does not have any other data. So why do you want that light? That will only smudge the output. Your camera is giving you that 3 data. You have to recreate it by that 3 data. Our eyes have that 3 data system. So don't, like, just pure recreation can only happen if your supply chain is clean. So once camera did the down conversion from broad spectrum to RGB, you do not want to add anything more. That's the easiest way of doing that. So quantum dot gives you that true rendition, meaning the color volume. Now, OLEDs always has the advantage. If you ever got a luxury of OLED, even older OLEDs, they looked amazing. Not because they were bright or color saturated. They were great because black was black. So it's almost like a sketchbook, comic book. And once the full coloring is done, they do inking. They highlight the black area. It looks great. OLED had that, meaning this TV, while it does not have the latest and greatest quantum dot and all that, it will still look amazing to human eye. If I shut off all the light, it will look mind-bogglingly good. So somebody figured out, hey, what if we had throw away the filter, add quantum dot, every problem solved. Your color volume expands, your energy consumption goes down, lifespan increases. There is only one penalty, because you are throwing away so many filters and polarizer and all that. Yes, there are polarizer, they are not showing it in this, but there's a lot of stack. Your black becomes gray. As in like, wait, how the heck that can happen? Yeah, your black is not gray because it's emitting light, it's reflecting light now. Once you have this thinner stack, if you are in an office room, like let's just say there is light, it will look a bluish, purplish. So even the screen is black, as in like in a dark room, it will be black, but it has enough reflection. Now people are working on creating new coatings that should allow this puppy to look good, but we are not there yet. Again, is that an issue? 99% of the time, no. Because if you turn off the light, like let's just say fully bright room, it looks like a quality LCD. Turn off the light, it looks like a great OLED. You can't do that with LCD. Like turn off light, it will look worse because the gray will become bright gray. So people still like it. And again, the core advantage from an office point of view or a monitor point of view is long lifespan. You're not overdriving it. So that's the whole thing. QD OLED. Now, even a newer concept came in, that is Tandem. Basically, what if you stack two of these puppy together? So OLED has only two major problems. Otherwise, it's the perfect technology. It's just that it has low brightness. Like this puppy is not very bright. Again, I don't need it because I have the luxury of controlling the ambient of this room. So I don't worry. But again, if you are in a place where you have a window, you can't shut down, it's like, yeah. So brightness is low. Lifespan is burnt. Like this puppy already burnt, like top, bottom, already burnt. So yeah, that's bad. But what if you had two of these puppies? Because here's the, why does OLED burn? It's hard driving, like it's forcing its organic layers, as in like the organic lead, to go yellow. It's like, but what if you need 120% output? Well, A, you can overdrive a LED and burn it out, as in shorten its lifespan, or you drive two OLEDs at 60% and get 120%. That way you can have higher brightness, what customer wants, and longer lifespan, which customer needs. Ta-da! That's your dual LED system. Now be mindful, how do you get that? That's up to you. There are two companies claiming two different things. One is saying that we have complete OLED, OLED 1, OLED 2, and LEDs in that is connected in series or parallel. You get to choose. Each one will have some benefit or cons. And LED is saying that, LG is saying that we have that. And then there is another LG claim that they have backlight that has been changed. I have no idea which one of these is the actual one. Although this Tandem OLED, where it has like full-fledged two OLED stack, that is more for LG industrial, as in their target is not you and I, not even TV or laptops or something like that. Their target is vehicle. Having OLED display on a vehicle, it's great, but short lifespan makes it useless. But if you have tandem system, now you can have the brightness that is needed, because if this puppy has to be visible in broad daylight, it will be visible and it will not burn out quickly. So you can hopefully expect this puppy to last 10 to 20 years. So, but price is stupid. Like you don't even ask about the price at this point in time. Quantum dot OLED is expensive because OLED is expensive. Quantum dot LCD is not that expensive. But this is bonkersly expensive. Having two OLED layers, it's expensive. Like painfully expensive. And again, in principle, assuming micro LED technology never reaches maturity, this may be a good solution. And by the way, you can still add a quantum dot on top of it, because we are still talking about light emitting layers. So quantum dot can still tighten it up, and then you can have a really long lasting good system. Although I could not even theoretically see that it could become cheap, like not even theoretically. Having two complicated panels merged together is like, yeah, that's not happening. Like not, like I can see that becoming a big thing, but like if you're rich, buy that, but like not as a practical, is an industrial thing, of course, but not as a general purpose monitor technology. Some company will try to sell monitors on that. Good luck. So this was my presentation on this whole idea of hybrid technologies that we are going with. Hopefully you have liked it, learned from it. In that case, please click the like button. If you enjoyed it, please click the hype button. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.